Hello everyone, my name is Jatin Nabboya and together with Farial Bahavi, we work on a reinforcement learning agent for a classic snack game. This project was done as a part of our artificial intelligence course under the instruction of Dr. Wahid Behzadin. Our goal was to design an AI agent that learns how to play snack from experience using Q learning instead of hard coding rules, and we let the agents explore the environment, learn from rewards and penalties, and eventually develop its own strategy to survive and reach the food. In this presentation, I'll walk you through our environment design, reward systems, and Q learning method. Begin with our project, we first build a custom 10 by 10 snack environment from scratch. Then we implemented a Q learning agent and created a baseline random policy to compare performance. We also built a fully Pygame interface that support both human mode and AI mode, where we can visually observe how the agent behaves. We added sounds effect for eating food, game over, and which makes testing more interactive. Overall, our goal was to deeply understand how reinforcement learning behave and to visualize the learning process using a simple but meaningful game. The agent receives a simplified stat representation consisting of snacks positions and food location. It takes four actions up, down, left or right. We design a reward function that guides learning: +1 when snacks eats food, -1 when it hits the wall, plus point 1 for moving closer to food, and minus point 1 for moving farther away, and 0 for normal move. This reward structure encourages the agents to move intelligently towards the food while avoiding risky moves that leads the collision. We train the agent using the standard Q learning update rules where the Q value is adjusted based on the reward and the discounted value of the next state, or hyperparameter where a learning rate of zero point 0.1, discount rate factor of zero point 0.9, exploration rate zero point 0.1, and 2000 training episodes. We store Q value using default dictionary to handle unseen state easily. Over time, the agent shifted from random exploration to consisting decision making and learning a stable strategy for reaching the food.
In terms of evaluation, we compared the random agent with the trained Q-learning agent. The random agent basically wandered and rarely ate any food. It usually died by hitting a wall, got negative rewards, and only survived around 30 steps. After training, the Q-learning agent behaved much better. It moved toward the food, achieved higher rewards, and ate more food per episode. So we can say confidently that learning happened and that the agent actually developed a policy. We also built a Pygame version of a snake, which I will show you in the demo. This version is separate from the RL environment. It's mainly for visualization and for human players. It shows what the game looks like and makes the project more interactive. It also has two modes, human mode and AI mode. And human mode, we control the snake with the keyboard. In AI mode, the snake follows a simple deterministic strategy. And also we added sound effects for eating food and for game over. In summary, we successfully built a complete oral pipeline, a custom environment, a trained Q learning agent, a baseline for comparison, and a visual Pygame demonstration. This project helped us understand Q learning much more deeply, from the math all the way to the implementation. Here's a demo of our project. I will start with the random baseline. This agent just takes random moves with no intelligence. You can see it wanders around, usually hits the wall and really eats any food. Its average reward is negative and it survives only around 30 steps. Next is the Q learning training. I trained the agent in my custom 10 to 10 environment for 5,000 episodes. The Q learning algorithm updates the Q table that stores the value of each step, state action pair. Reward shaping helps guide learning by giving small penalties or bonuses depending on movement. Now I will run the trained agent. Here's a trained agent. So this uses the Q table produced during training. And you can see the agent chooses actions intentionally instead of randomly. So as it moves, we can see the total actions taken, the foods eaten, and the total steps the snake takes. So we can see clearly that that's better than the baseline. And finally, this is the Pygame version of the game. This part is separate from oral actually, and it's used mainly for visualization. It has two modes, human mode and AI mode. In human mode, we can use the arrows, and in AI mode, it is a simple strategy, and it also includes sounds effects for eating and game over. So the idea of this part is to show the game visually and interactively, while the oral training happens in the abstract grid environment. Thank you.